moved on from hot deserts, and now we're going to have a look at climate change over the next few lessons. So again, I've recorded this lesson to help you out. It goes alongside the work that you've been set either on Teams or emails. So when I say in this video, pause now and have a go at this task, the tasks are also outlined on your work on Teams as well. Make sure that at the end of the video, when you've done your work, that you're emailing it either to myself or Miss Madare. A few of my classes, we have started already looking at climate change before the lockdown, but that seems like a million years ago now. So that's why we're starting again from the beginning. If you do find that it's all coming back to you really easily, and you want a bit of an extra challenge, just drop me an email and I can send you some further tasks to do. Okay, so what we're going to have a look at today, and the focus is all on evidence for climate change. So our aims are to define some key terms, so climate change and the Quaternary Period, and to explain how we know climate change is happening. So that's a little bit from the AQA, our exam board specification, and we're focusing on that top little bit here, evidence for climate change from the beginning of the Quaternary Period to the present day. So that's why I said we need to define what this term means. Okay, so we'll start with climate change first. If the whole topic's going to be about climate change, you need to know what that is. So in terms of a dictionary definition, climate change refers to a large-scale, long-term shift in the planet's weather patterns and the average temperatures. And I've got a little bit of a video just to introduce climate change and some of the key concepts with you. So if you have a watch at this, just bear with me, and hopefully it'll play. I say hopefully, it never goes right.
This is the world. That's you and that's me. The world has the perfect temperature to keep all living things alive and happy. This temperature depends on a balance. The sun's heat goes to Earth to make it warm. The sun's heat bounces back to space to make the Earth cool. When this balance is lost, the climate changes. The Earth's climate has changed many times before. This is called natural climate change. It's caused by volcanic eruptions, changes in the sun's energy, and changes in the Earth's orbit. Greenhouse gases also make the Earth warmer. They trap heat from the sun. Greenhouse gases are like a blanket covering the Earth. It started in the 1700s. Humans started to build more things. We burned coal to make electricity. We burned oil to make our cars and planes move. We use chemicals to make things. We cut down lots of trees. We burn gas to cook food. We dump lots of trash on landfills. We plant a lot more rice. All these things release greenhouse gases. Remember the blanket over the Earth? Because of humans, it got much, much thicker. When I get hot, I sweat. I even get dizzy. Imagine the Earth. Because it's hotter, glaciers and ice sheets are melting. Seas are rising, storms are getting stronger, some places are getting dry. Even the sea is getting warmer. All living things are in big trouble. So what should we do? We need to change the way we live so we can stop releasing so much greenhouse gases. That way, the Earth's blanket will go back to normal. We also need to be ready for what climate change will bring. In December, there will be a big meeting of nations. They'll meet in Paris to decide how each country can help. Their decision will decide the future of Earth, our home.
So I thought that video was a nice little introduction. It was recorded a few years ago now, because it was December 2015 where countries met in Paris for what we call the Climate Summit. So they met and agreed on different things to try and tackle climate change as different groups of nations. Okay, so the next key term that I said we need to define was the Quaternary Period. So basically, there's a diagram here showing all the different time periods. So Earth formed 4.6 billion years ago, and we have to know about this Quaternary period. And can you see where I put the red box around? That's the Quaternary period. So from now to around 1.8 million years ago, we need to know what evidence is out there that climate change is happening. So that's what we're going to have a look at today. We're going to explain how we know that climate change is happening. Okay, so as normal in normal lessons, we do some skill starters or throughout the lesson. So I thought we could start this as your first task. So there's a line graph there that shows the area of sea ice measured in million square kilometres. What I want you to do is study the graph that shows the area of Arctic sea ice. It goes from 1979 to 2016, and I want you to describe how the area of Arctic sea ice has changed. There's a little bit of guidance of how to answer these types of questions using the acronym T. So what is the trend? So is there a pattern? Is it increasing? Is it decreasing? Is it going up and down? So fluctuating. E is use evidence from the graph. So use numbers, use dates, say how much it's increased or decreased by, and so on. And then A, is there any anomalies? Was there any years where it didn't fit the trend and didn't fit the pattern, if there is one? And a little bit of a challenge task for you. Explain why a line graph has been chosen to present this data. So why is that a good graph to present that geographical information? So if you can pause it now and have a go at that task, please. Okay, moving on. So Donald Trump, the president of the United States of America, has been quite vocal in his opinions towards climate change and global warming. And that is a quote from him there. So he's not a believer in global warming. He's not a believer in man-made global warming. He said it could be warming and it's going to start cooling at some point. So what we're going to have a look at today is some bits of evidence that proves him wrong. Global warming is happening and man-made global warming is definitely happening. So here's a little bit of evidence. So the Earth's average surface air temperature has increased by approximately 1 degree Celsius over the last 100 years. Now you might think a degree, isn't a huge difference. If you walked outside and it was 21 degrees and then you walked outside and it was 22, you wouldn't feel that. However, that a 1 degree increase can have massive effects. And if you do have some extra time after this video, if you just type into YouTube what would happen if the Earth was 1 degree warmer, 2 degrees, 3 degrees, and so on, and there's some quite interesting videos about what the impacts of that would be. Another piece of evidence is that sea levels have risen by 19 centimetres since the year 1900, and that's due to what we call thermal expansion. So as something heats up, it gets bigger. So as water is heating up, it is expanding. So then the sea level's rising, and then the ice sheets are melting as well due to the increased temperature. Ocean temperatures are the warmest they've been, and then glaciers and ice sheets are continually decreasing in size. So what I want you to do, Antarctica loses 134 billion tonnes of ice per year. Okay, so what I want you to have a go at in a second is pause the video. There's a made-up tweet there from Donald Trump saying climate change is not real. I want you to reply to Donald's tweet proving him wrong, and try and do it in 140 characters or less. Okay, so what we're going to have a look at now is we need to explain how we know climate change is happening. And another key term is something called climate proxies. So proxies, physical characteristics of the past that scientists use to help reconstruct past climatic conditions. So, it's like, how do we know what the climate was like, before man and woman existed? So what evidence is there that's out there that scientists have used to prove past conditions? And what we're going to study today are four different types. So we're going to have a look at tree rings, fossil pollen, ice cores, and ocean sediments. and they're all different ways that scientists can use to help them to determine what the climate was. So on the Teams work or email work, I've put a table together that's got each of the different proxies, and you need to answer the question for each one. How does each proxy help us to learn about climates in the past? And to what extent can we rely on it? Is it reliable? Is it trustworthy? Is it accurate? And so on. And an extra challenge for you, out of the 4 proxies, which one do you think is the most or least reliable, and why? I'll talk through one example with you just so you know what I mean and what I'm asking of you. So tree rings is an example of a climate proxy. So a tree can be chopped down, and then as that picture is there, you can look at the different tree rings, and each year that a tree grows, it develops a new ring. If the ring is really wide before the next one, that would indicate a warmer climate, and if it is a lot smaller, it would indicate a lot colder climate. But there is more information in your Teams or email pack. If you could pause and have a go at those tasks now, please. Okay, so bringing it together, what I want you to have a go at, and I've given a couple of examples first before you have a go, I want you to explain 2 types of evidence that can be used to show that climate change is taking place. So I've already booked the answer question, which we asked you to do in exams. So box the command word, which is explain. So I'm having to say, you know, what a piece of evidence is and how that shows climate change is taking place. Underline the geography, so climate change, and then the G, that always refers to glance back to the question as you're writing the answer to make sure you're sticking to that question. So there's answer A there and answer B. What I want you to do is just have a look through those and have a read and tell me which answer is best and why. So answer A, people can look at tree rings for evidence of climate change. People could also look at ice cores and analyse the gas trapped inside of each layer. And then answer B, people can look at tree rings for evidence of climate change. The wider the tree ring, the more it has grown, suggesting that it was warmer that year. Tree rings can then be compared to see the changes in climate. So just have a quick think, which answer do you think is better and why? It's a little bit of a trick question there because these elements of good things about both of them, and this is really important why you read the question. I bet all of you thought initially and it's explained. They've said what the tree, they've identified, that the tree ring is a piece of evidence, but then they've explained that the wider the tree ring, the more it's grown, it suggests it was warmer that year. That can then be compared to see past climates, which was really good. But if you glance back at the question, it says explain 2 types of evidence, and obviously they've only explained 1, so that's really important that you are picking that out when you're reading exam questions. And then answer A, they haven't really explained, they've identified 2, so they've identified tree rings and then gases that are trapped in ice cores, but they've not gotten on to explain that. So again, neither question would have got 4 marks, and I know that you are all more than capable of getting 4 marks and doing better than answer A and answer B. So what I want you to do is pause the video now. This is the last task for you to do. Have a go at answering that question yourself. See if you can get 4 out of 4. So you'd need 2 well-explained pieces of evidence that can be used to show that climate change is taking place. So use the information from the previous task about the ice cores, the fossil pollen, the ocean sediment and the tree rings. Pick 2 of those and explain them really well. And then if you could either take a picture of your work if you've been handwriting today, or submit it on your Word document, whatever you've done that on, via email or via Teams, either to myself or Miss Medare. Thank you for watching again, Year 10, and keep up the good work. Take care and stay safe. Bye-bye.